All right, let's look at the first one from the worksheet. Our mean value theorem. So we are looking for the value of C that satisfies the mean value theorem. So the first thing we got to do is find the mean value. So that would be the average slope in this case. So let's go to point 3, and it looks like it's at 3, -2. I could also put a 3 in here and get the output of -2. And let's go to 6, 6, -5. And we can write our slope, the y value of -2 minus -5 over the x values of 3 minus 6. I think that's going to get me 3 over -3 or -1. Clearly this line has a slope of -1. Now we can talk about what the mean value theorem means. We just looked at a video on it. Let's see if I can get this line to move. That line has a slope of 1, so we can kind of predict what point from 3 to 6 has the same value. Looks like it's somewhere over here. So we need to set the derivative equal to that value. That's our value of C. So if I solve that, I subtract the 9 divided by the -2, x equals 4.5. Does that look right? The answer sure makes sense to me. So the value is 4.5 satisfies the mean value theorem. And the video you just watched, why does the mean value theorem apply? Because the function is continuous and differentiable. Good. And then if we flip over to the back, for each problem, determine if the mean value theorem can be applied. If it can, find the value of C, all values of C that satisfy the theorem. If it cannot, explain why not. So let's look at that first one. What do you think? From -4 to -1, if I graph this function, as I said, that can't be equal to 0. X can't be -2. What do you think's happening at -2? It's got to be some kind of an asymptote. Therefore, the mean value theorem does not apply because the function is not continuous. It's really that easy to say, nope, can't use the mean value theorem. All right, continue. Finish the worksheet.